We'll now continue with example 4. In this example, in our previous slide, we saw that xt was found to be this equation here. 6 plus 10e minus 5t cosine 3t plus 126.9 degrees with a unit step. Now, we can use MATLAB to solve for the same problem. What we do is that we give MATLAB this expression, and then directly we ask MATLAB to perform the inverse Laplace transform, and this is possible using such an equation here. First, we enter the equation in MATLAB. First, remember to define s and t as symbolic variables. Once we have done this, then we can use the inverse Laplace given the input as x of s, and we'll get x of t. Well, for sanity check, I send the x of t back to verify x of s1, and then again for sanity check, I send x of s1 into the inverse Laplace to get x of t2. So if everything works out, this should be correct, as well as xs1 should be this value. Okay, so this is our answer over here. We have sent x of s. It gives us this x of t. The answer looks a little bit different from our answer, which is here below. Let's inspect it more carefully. Well, the 6 is there, as well as we have exponential minus 5t, which is here. The difference is in that we have cosine of t as well as sine of t, sine of 3t and cosine of 3t. So what happened is that it is different to our solution above because it has expressed a cosine 3t plus theta into some cosine of 3t times variable, let's call this variable alpha, plus sine 3t beta. That's the difference. So what happened is that you can use the trigonometric identity to find what is alpha and beta, and you realize that MATLAB has done it this way, and the answer is the same. In fact, the other strange thing, of course, is that when we try xx1, which is here, we take MATLAB solution and we perform Laplace on it, the xs expression doesn't look like our original expression. However, when we take inverse Laplace again, the time solution remains the same. Alright, so the key idea is that when you see that MATLAB doesn't give you the same solution, please don't panic. You know, it could have been one of these problems that we had, and then you have to work out the different expression as sum of cosine and sine. Alright, with that, I'll leave it to you to look at some of these references which I have found interesting. Lati and Green produces a very good book, as well as Phillips and Parr in the various chapter. Okay, thank you.